This is an advanced algebra video, factoring polynomials. We're in topic 7. This is section 4. Factoring polynomials, factoring specifically quadratic equations is a huge part of algebra. And we have to jump through some hoops before we get to the final part of it where we could finally look at the application and say, oh yeah, that's why we had to learn this. Okay, so that's kind of the process that we're in now. And so what they want us to do here first is to just find the greatest common factor and factor that out. And so, if we look at 12, 8, and 6, the greatest common factor between those three numbers is 2. And the way I get that, I pick the smallest number, which is 6, and its factors are 1 times 6 and 2 times 3. So of those four numbers, what's the biggest one that goes into divides evenly into the other two? And the answer is 2 in this case. And then when I look at x cubed, x to the 4th, x to the 5th, at most, how many x's do they have in common? And it's x to the 3rd. And then factoring that out is like dividing. Okay, so it's like I'm going to take 12x to the 5th and divide by 2x cubed. And 12 divided by 2 is 6. And x to the 5th divided by x cubed is x squared. That's how I get that term. And then I go on. I divide this next term by 2. I get 4. And x to the 3rd divided by, or x to the 4th divided by x to the 3rd is x. And then 6 divided by 2 is 3. And the x cubed divided by x cubed. And so that's where changed brightness, and so I thought my battery was going. Anyway, moving on. We have and I actually went beyond what I needed to do. The directions are to just find the GCF. It doesn't say to factor it out. Just find the GCF of the terms of each polynomial. So technically my answer here was 2x cubed. So my answer here, 15 is the smaller number, 1 times 15, 3 times 5. The greatest one of those that goes into 18 is 3. The greatest common factor is 3. We are going to get to the point where we are factoring it out. And so I'm going to go ahead and say, if I factor that out, I get 5x squared plus 6. When I look at 18, 6, 24, see 1 times 6, 2 times 3, 6 goes into 18, 6 goes into 6, and a lot of times when our leading coefficient, okay, standard form, when our leading coefficient is negative, we like to factor out a negative 6, and then y squared would be my greatest common factor. If I went ahead and did that, I would have 3y squared. Because I factored out a negative, this would be minus now y, and then minus 4. And again, what we're leading up to is that eventually we'll be able to factor that trinomial. Again, they were just looking for the greatest common factor, but I went ahead and factored it out. And then that's what we're doing in these next problems, is not only find the GCF, but to factor out. So when I look at 12, 18, and 27, I believe the greatest common factor between them, I'm going to factor out a negative 3. Between x cubed, x squared, and x will be my greatest common factor. So and I'm just dividing. So I get 4x squared. 18 divided by negative 3 would be negative 6x. And then negative 27 divided by negative 3 would be plus 9. And next one, they don't have any numbers in common, but we do have an x in common. So we can factor out an x and have x squared plus 5x minus 22. Next one, 16, 28, and 20. I think it's going to be 4. And again, I'm going to take out a negative 4. And y to the third, because the smallest is 3. The smallest is 3 on the y. So I'm going to get 4y to the third plus, oh no, minus, if I factor it out a negative, minus 7y plus 5. I think my next greatest common factor here is 50. And then a to the 7th, b to the 3rd, and 100 divided by 50 is 2. I'll have a b squared there. 150 divided by 50 is 3. I'll have an a there. That's it. Sorry, had to have another dog in. Big dog wants to sleep in the little dog's bed. The little dog is crying. She wants to sleep in the little dog's bed. So I just had to kick the big dog out of the little dog's bed. The circus here. Thank goodness. You just have to see the paper. Anyway, the farmer wants to plant 3 rectangular fields so that the widths are the same. We have 3 rectangular width fields, right? So the widths are the same. Okay. And the areas of the fields are 12x squared y, 9xy squared, and 21xy. What is the width of the field if x is 3 and y is 12? So I'm going to have 12 times 9 times 4. There's a little help from my calculator friend here. That's going to be 9 times 48, which is 32. This would be 9 times 3 times 16, which is also 48 times 9, which is 42. And 1 times 3 times 4. Basically, what we want to do is find the greatest factor between those. 252 divided by 12, 432 divided by 12, um, 652 divided by 56, 432 divided by 56. So what I did was, the 12 times 21, obviously there's another common factor they have. 21 has a 3, 36 has a 3, and 36 has a 3. And so I changed this one to 36 times 7 instead of 12 times 21. And so I could have set up above 12 factors that I did above, but that's not their greatest common factor. Their greatest common factor is 36. So the width of each one is 36 units, whatever are there. Okay.